Hi everyone, welcome to the lecture on Laplace Transform. In this video, we are going to discuss how to solve this differential equation. Here y double dash plus 9y equal to 6 cos 3t with initial condition y of 0 equal to 2, y dash of 0 equal to 0 using Laplace Transform. So when we have given the differential equation, so we have to apply the first Laplace Transform so that this is actually the function of t. So when we apply the Laplace transformation, so you will get answer in the form of s. After that simplification, you have to apply the inverse Laplace transformation to get the final solution of this differential equation. So this question asked by the student in the comment section, that's why we are going to discuss its solution. If you also having the doubt in the particular question, share your doubt in the comment section. And I have already covered the Laplace transform complete topic, Laplace transformation, their properties, example, Laplace inverse, application of Laplace transformation, also this how to solve simultaneous differential equation with the help of Laplace transform, unit step function and inverse Laplace transformation. So each and every topic with many example I have already covered. If you want to watch that video, the link of the playlist is given in the description box. Also at the end of this video, you can find the playlist of Laplace transformation. And most important, the maximum question I have covered which was asked by the student in the comment section. So might be you also having the same doubt, so it will be clear through that videos. So let's see how to solve this example. Here is a differential equation. In the first step, apply the Laplace transformation. And through this video, I will explain stepwise how simply you can solve this type of question. So when we have given the differential equation, so write down that differential equation. Here the given differential equation is y double dash plus 9y equal to 6 cos 3t. In the next step, apply Laplace transformation. That will be our first step. So when we apply the Laplace transformation, so we have to apply both the side, and we know that Laplace satisfying the linearity property. That means term wise you can separate the Laplace and take the constant term outside. So Laplace of first term, so Laplace transformation of y double dash plus 9 is constant, Laplace transformation of y equal to 6 is again constant. Laplace we have to apply on the function cos 3t. Now here either you can directly write down the Laplace transformation of y double dash, otherwise you can find the Laplace term wise separately. Means here this is a y double dash. So what is the formula of finding Laplace transformation of y double dash? If it is a double dash, to start with the formula s square. Here 3 dash, then you have to start with s cube and reduce the power of s. So it is a s square y bar of s minus s y of 0 minus y dash of 0. How we get this formula? That we have already covered in the property of Laplace transformation, derivative property. So using that property you will get this formula. Now here initial condition y of 0 is 2, y dash of 0 is 0 is already given. So you have to use that condition. So put y of 0, use the initial condition, y of 0 is 2 and y dash of 0 equal to 0. If we put this value here, so we will get y double dash is s square y bar of s. So y of 0 is 2. So you will get here 2s and y dash of 0 is 0. So no need to write here. So here this is the value of y double dash of s. Now Laplace of function. So when we find Laplace transformation of f of t, so when we find Laplace of f of t, so you will get here f bar of s. Similarly, instead of function f, here in this question we are using the notation y. Means it is a Laplace transformation of y is actually showing the Laplace transformation of y of t. And see here, instead of f it is a y, so you will get here y bar of s. Now here Laplace of y is y bar of s. Now the right side is cos. So here you have to use our formula. We know that Laplace of cos at is s upon s square plus a square. So using this formula, here cos of 3t. So instead of a, it is a 3. So write down here 3. So you will get s upon s square plus 3 square you can write. Otherwise you can write 3 square is nothing but 9. So this is the answer of Laplace of cos 3t. So we know the Laplace transformation of y double dash, Laplace of y, and Laplace transformation of cos 3t. So put all this value in this equation. Let's consider it is a equation number A. So in a equation A, if we put the value, so put all the values in equation number A. So first term is Laplace transformation of y double dash, which is a s square y bar of s minus 2s. Next is plus 9 y bar of s. So plus 9 y bar of s equal to, here right side is 6 is outside constant term. Here it is a 6, and Laplace of this term is s upon s square plus 9. In the next step, collect the term of y bar of s. So this is the term containing y bar of s, and this is also contain y bar of s. So keep this term in the left side. Remaining term without containing y bar of s, that you can shift in the right side. Means this 2s we have to shift in the right side, and this minus quantity shifting will be plus. So here in this first and last term, if we take y bar of s common, so here it is a s square, and in this term it contain plus 9. So here y bar of s is common, and right side term is 6s upon s square plus 9, and this minus term shifting will be plus, so it is a plus 2s. Now in the next step, this term extra quantity other than this y bar of s, whatever the quantity is there, you have to shift in the right side, because when we are solving this differential equation, that means you have to find a solution, and solution is nothing but we want answer y in the form of function of t, means y equal to you want. So y equal to, you have to find out function of t. So we have to write here y bar of s equal to every term. So here this s quantity, if we shift in the right side, so it is in multiplication, so it will be in the division and contain two terms. So each term divided by this bracket. So here if we divide by s square plus 9, so you will get here y bar of s left side equal to 6s upon s square plus 9 whole square, because already there is a bracket this one, and again we are dividing this term, so there is a bracket square, plus 2s upon s square plus 9. Now in the next step, you have to apply the Laplace inverse both the side, because you want answer y equal to, so it is a function of s, but we want the answer in the form of t. So once we get the s term, so after simplification you have to apply the Laplace inverse. So in the next step, apply Laplace inverse both the side. So we will get Laplace inverse of y bar of s equal to, here 6, again it is a constant, take outside, Laplace inverse of s upon s square plus 9 whole square, plus here it is a Laplace inverse, again 2 is a constant, you can take outside, Laplace inverse of s upon s square plus 9. Now the next step is important, how to solve this Laplace inverse, because this up to this step you can solve easily, but the task is how to find the Laplace inverse of this two terms. So I will explain how to solve Laplace inverse of this term. Two methods. First method, directly you can apply the formula, and another method is the regular process of finding Laplace inverse, which you can use by convolution theorem or partial fraction, but you can solve this question directly with the help of formula. So now see how to solve the Laplace inverse of this particular term. We know the Laplace transformation of sin 80. Yes, Laplace transformation of sin 80 is a upon s square plus a square. And what is the property of multiplication by t? When we are multiplying the function by t, so what is that property? When t into, if we take the function, so the property is minus 1 d by ds of Laplace transformation of the function. So when we multiply t, then it is a minus 1 d by ds of Laplace transformation of function. So t we are multiplying to sin 80. So function is sin 80. So the Laplace transformation of sin 80 is a upon s square plus a square. So I am just applying multiplication by t property. As I am explaining, that's why it takes a time. So find out the derivative of this term. So here the minus 1 and a constant as it is, 1 upon s square plus a square, derivative is minus 1 upon s square plus a square whole square, again derivative of bracket term. So again derivative means it is a 2s. So here the derivative of this term, so derivative of 1 upon x is minus 1 by x square. So using this formula, here a is constant outside, 1 upon this term, derivative is minus 1 by whole square, and this is a function. So again derivative of this term, so s square derivative is 2s and a square is constant, so that's why derivative becomes 0. So this is the derivative of this term. Now here this minus and outside minus, that become plus, and 2sa. So here it is a 2as upon s square plus a square whole square. This is the Laplace transformation of t into sin 80. But in this question there is 3 instead of a, it is a 3. So if we put a equal to the value of constant 3, then it is a Laplace transformation of t into sin 3t equal to, here a is 3, so 3 into 2 is 6, so 6s upon s square plus, here it is a square is there, so s square plus a square is 9 whole square. It is a square plus a square, and a is 3, so 3 square is 9. Now this, if we apply the Laplace inverse both sides, so you will get t into sin 3t equal to Laplace inverse of 6s upon s square plus 9 whole square. That means Laplace inverse of this term is nothing but t into sin 3t. So here is the same term 6s upon s square plus 9 whole square. So using that term directly you can write here t into sin 3t plus 2, and this is a standard formula, Laplace inverse of s upon s square plus 9. See here it is a cos 3t. So here cos 3t, and left side is Laplace transformation of y bar of s is y of t. Hence we get the solution of our given differential equation. But when you are using the direct answer, so that time you have to mention this formula in the exam. Means using this formula, so here the Laplace inverse of this term directly we are writing t into sin 3t. So here you have to mention the formula, that is Laplace inverse of 2as upon s square plus a square whole square is t into sin 80. Means using this formula we are writing this answer directly. Otherwise in the exam you can mention this step and then after that write down the final answer. Now this is the first method to find the Laplace inverse of this term. There is another method that you can find the Laplace inverse of this term using convolution formula. So I will explain the second method. You can use any method in the exam as per understanding, but if you are using this direct formula then you have to mention that formula, otherwise few steps how we are getting this formula. So what is the convolution theorem? So if there is a Laplace inverse containing Laplace inverse of f bar of s into g bar of s equal to, it is a integral 0 to t f of u g of t minus u du. So here our given question is Laplace inverse, we have to find 6s upon s square plus 9 whole square. So you have to write this term in the form of product. So I will take first term as a 6 upon, so Laplace inverse of, here Laplace inverse of first term 6 upon s square plus 9 into s upon s square plus 9. If we take the product of these two functions, so you will get this one, s into 6 is 6s and bracket into bracket is bracket square. So same term I have split it into the product of two function. Now first we consider as a function of f and second is a function g. So here f bar of s is our 6 upon s square plus 9, and if it is a f bar in the form of s, so if we apply the Laplace inverse both the sides, so you will get Laplace inverse of f bar of s is Laplace inverse of 6 upon s square plus 9. Now 6 can we write 2 into 3? Yes, this 6 is nothing but the product of 2 multiplied by 3. 2 into 3 is nothing but again 6. This 2 constant we can take outside and remaining is Laplace inverse of 3 upon s square plus 9. 9 is again a 3 square. Why I have written this one? Because it is a formula of a upon s square plus a square, that is a sine at. Here 2 as it is, and this is nothing but the sine 3t. Laplace of sine 3t is 3 upon s square plus 9, and Laplace inverse of this term is f of t. Now here second is our function g. G bar of s is s upon s square plus 9, and if we apply the Laplace inverse both the sides, so you will get Laplace inverse of s upon s square plus 9, and this is again a standard formula. It is a Laplace inverse is a cos 3t. So this is the cos 3t, and left side Laplace inverse of function g. It is a s form inverse, we are getting the answer in the form of t. So this is a function of g of t. But for theorem you want f of u and g of t minus u. So for theorem I will write instead of t variable u. So you will get f of u is 2 sine 3 u. So here t replaced by variable u. So f of u equal to 2 sine 3 u. So it is a sine 3u. Now here t variable you have to put t minus u. So t variable replaced by t minus u. So you will get g of t minus u equal to cos 3 in bracket t minus u. That means it is a cos 3t minus 3u. Put this value in this formula equal to integration 0 to t. Here f of u is our 2 sine 3u and g of t minus u is cos 3t minus 3u du. In the next step you have to solve this integration. Here sine and cos in the form of product, so directly not possible. Again here you have to use the trigonometric formula, that is a sine a into cos b. The formula is 1 by 2 sine addition of angle plus sine a minus b. So use this formula to solve this integration. So using this formula, here sine 3u into cos 3t minus 3u equal to 1 by 2 in a first bracket addition of their angles. So addition of angle means here if we take the addition of this two angle, so 3u minus 3u 0 and remaining is 3t. So plus addition of the angle plus sine subtraction of angle. So 3u minus of this term. So you will get here 6u minus 3t. Because if we subtract this term, so it will be changed the sign minus 3t plus 3u, and this 3u plus 3u is 6u minus 3t. So now here put this value in the integration. So Laplace inverse of, so here left hand side is Laplace inverse of f bar of s into g bar of s equal to integral 0 to t 1 by 2, and there is already 2 in the multiplication, so that 2 I will write as it is, and product of sine into cos, product of sine into cos is here sine 3t plus sine 6u minus 3t dt. In the next step, this 2 to get cancelled and separate the integral term wise. So here integral 0 to t sine 3t into du plus integral 0 to t sine 6u minus 3t into dt. Now here we are integrating with respect to u. So obviously this t term is constant, we can take outside. So here sine 3t is outside, remaining is du, and integration of du is u integral 0 to t, plus here integration of the sine term, integration of sine is minus cos 6u minus 3t divided by, here we are integrating with respect to u, it is a u. So when we are integrating with respect to u, so that variable multiplication constant term you have to write in the denominator. So 6 we have to write in the denominator. Limit is 0 to t. Put upper limit minus of lower limit. So upper limit is t. So here t sine 3t minus of lower limit, that means you will get here 0. So no need to write 0, plus here upper limit is t. If we put here t, so you will get minus cos 6t minus 3t. So it is a 3t upon 6 minus of lower limit. So lower limit means here 0 you have to put, and minus sign is already there. So minus of lower limit, and there is already minus. So minus of minus plus cos t, here u we have to put 0. So if it is a 0, so it is a minus 3t divided by 6. And cos is a even function. So if angle is negative, positive, remain same. That means here cos of minus theta equal to cos theta. If this is the condition, so it is nothing but cos 3t. Cos 3t divided by 6 and minus cos 3t divided by 6 becomes 0. So actually here using this formula you can write it is a cos 3t, and this cos 3t divided by 6 and this negative term is 0. That means this bracket is 0, and this is the t sine 3t. So using convolution theorem, if we find the Laplace inverse of this term, so ultimately this Laplace inverse of this term by convolution theorem, it is a t sine 3t. Hence we get the same answer. So this term, if we find the Laplace by convolution theorem, so answer is t sine 3t, and this is the term whose Laplace is a standard formula 2 cos 3t. So both methods are correct, giving the same answer. So thank you for watching. I hope it is clear to you. Still, if you have doubt in the steps, you can share your doubt in the comment section. Thank you for watching.